Okay, there's a lot to go over in this video, and I'm no expert on any of this, so bear with me. But we've got some knowledge dump that is due. So the quick history is that Justin DM was looking around to see how Frigate Secret World worked with the aid of Blender. Because of the Metaforce team, we're able to look at the level collision from this game as Blender files. So I am new to Blender. I don't know how to do any of this stuff, but I'm going to try and explain what's been discovered about Reposition Secret Worlds in the past couple of days, because it's a pretty big deal. So the first thing to note, this is the Frigate Secret World. You reposition through this seam right here. If I can click on it. We used to think that it was just like where two pieces of collision met together, there might be a chance for the repo logic to let you go through that. That's like not true. And I suppose what I should do right now is just explain a bit about how the reposition logic works, because this is also relevant. So we'll say that this is Samus's morph ball. If it's obstructed, so you morph beside a wall, we'll say this is the wall here, this is a bird's eye view. Samus's standing collision box is about this big, approximately. So when you morph, you gain collision in, the axes, because Samus's collision box is axis aligned. It doesn't turn with you when you turn. It's just always, the sideways shape of it is about like this. This being the top, which is what we're showing here. When you morph beside a wall, it causes a reposition away from the wall. What would happen is you would reposition to like here, just to like show that without overlapping, this far away from the wall. But if there's something blocking you, say there's like a second wall right here, then you'll either get stuck or you'll get repositioned in this direction or the other direction, one of these two. And when that happens, there's a series of checks that's done. Essentially, the game draws a line from the center of the morph ball here to like, it'll go straight to the side and then straight to the side the other way and then straight up and straight down, and then it'll start doing diagonals, and then it'll start doing triagonals. I don't know what the word is, but when like you have the XYZ axis, which I don't even know if I can quickly like conjure up. Maybe you have a wall like this and you morph behind it. I can't click on the right things ever, apparently. So this is now like the sideways view. You might get a reposition that pushes you up, so that the ball goes from where it currently is to like up here to be freed. Anyway, all of that stuff, hopefully that makes sense. I don't know if it does. But what the game also does is each check is done at a fixed unit, and it starts off incredibly small. It's like 0.01 units, so it'll like test this way, this way, this way, this way, diagonals, all the other things. It's like, okay, none of those checks worked. Make it 0.05 units. And it'll keep checking that. It goes up like logarithmically, which it stops at 3.55 repeating. And the morph ball is 1.4 units big, so like, 3.5 is going to be, I don't know, maybe this far, something like that. To where the ball would go to like here. Something like that. It's like approximate. Anyway, the path has to not be obstructed by collision of any sort. So all that stuff I was talking about on MS Paint, this space here is basically the real version of that hypothetical. You can walk into this space, Samus can fit in here standing, but when she morphs, her morph ball will be stuck inside this wall, and this wall, which you only need one to trigger a reposition, but since all of them are there, they obstruct her from going anywhere. The check for where you're going to go is drawn from the center of the morph ball. So if she tries to go back this way, she's still going to be inside this wall. So that's like entirely just considered, you can't go there at all. If you try and go up, it's the same thing. You try and go up 3 units, you're still inside these walls, so that's considered invalid. And you actually can't even go diagonal here because it's drawn from the center of the morph ball and it only goes along the diagonal. So it ends up colliding with this wall. So when you morph in this, hold on, Blender is confusing my brain horribly. When you morph in this area, there's no viable spot for the game to reposition you, so you just get stuck. Except if you morph in a really, really specific spot, you get repositioned through this corner. So why is that possible? The answer is that this room is modeled not very well. So one thing we can do with Blender, this is the sort of like new discovery over the past couple of days, we can look for non-manifold edges, which are essentially when things like aren't welded shut, is maybe the way to think of it. That's kind of how I've been thinking of it. It's essentially that these two collision triangles aren't actually like connected. But if they share the exact same coordinates, then there still isn't a hole because you essentially have an infinitely thin line. There's no time there's ever a space there. Fortunately, and this is kind of ridiculous and why I mentioned that the room is just made badly, for some reason these two walls have different heights, but they also have marginally different XY values, which this one's 45 and 23 as like the last 2 digits of the 4-digit whatever it's called. 45, 23, and then this one here is 44. So in the x-axis, this point is actually like slightly, I forget which one's which actually, now that I think about it, but it's either slightly farther this way or slightly pulled back this way. And what that does is it creates an angle essentially. So instead of like your 2 points being this perfectly straight line where there's no, it doesn't matter how much you zoom in, there's no hole ever. It creates something that is more, and hopefully I can draw this like adequately. It should be like, should be able to imagine, tiny bit off, which means that at the bottom it's basically touching, and the higher you get up, the further apart they are. They're apart from each other at, like a microscopic amount though. I think it was this coordinate, right? 23 and 24. No, it wasn't. Was it this one? 45. Yeah, 45 and 44. That's what it is. So it's 0.0001 units gap here, and it just gets smaller on the way down. But it exists, which means that if we have perfect positioning, we can slip through that seam because there actually is a hole, which is a really important thing to note. And we can see the hole stretched out, the fact that it's a non-manifold, by warping the collision in Blender. You can see that there's like a spot here that doesn't check out. If I open this up like a door, you can see that they're just not connected. But if this shared the same coordinates, there still wouldn't be a hole. But because it doesn't, there is a hole. Which pretty much means that seam repositions not possible, period. If a seam has 2 identical vertices on either side of it, it doesn't matter if the collision is non-manifold, you cannot go through it with a reposition. I'm saying this as a result of my research trying it. I can't say this as like a definitive like programming point, but I cannot get these to work unless there is a hole. I think that there needs to be a hole because I've gone in quite a bit of detail over the past couple days trying to iron this out. So this is a secret world and this works. There are other secret worlds that we thought might be possible that just straight up don't work. And then there's more ambiguous ones. And I'm gonna make another video right now So this one's ending, but there's another one that I'm going to make, talking about Furnace, because I was just looking into Furnace, and I want to like showcase how these ideas can be used to potentially find new secret worlds, even though Furnace didn't really work. So, new video starting right now. Okay, this is the video number